writing chemical formulas, you've been naming chemical formulas. Now, what are they good for? Lots of things. The first thing we're going to do with those chemical formulas is we're going to start doing formula masses. This sets you up for coming back to, guess what? Stoichiometry! Woohoo! Bigger and better stoichiometry. So, we can find the mass of a molecule or a formula unit of a substance. Now, water is the example that's done for you in your notes. We just take the mass of each atom, multiply it by the number of atoms that are there, and add up our totals. That's pretty easy. This is easy stuff. The only mistakes you're going to make on this are dumb ones. So I'm going to lead you down the path to every dumb mistake I can try to get you to make today so that you don't make it again. Okay? I love the path to dumb mistakes. So let's start off with something fairly straightforward like sodium chloride. Okay? You'll need your best friend, the periodic table. Mass of sodium is what? Somebody in black or gray? 22.99 AMUs. And this is sort of a shorthand that I use when I add these up. When we start doing bigger stoichiometry, if you look at my key, you'll see on the side a bunch of these little notes where I've figured out formula masses for myself. Okay, and how many sodiums do we have? Just one. And chlorine. What's the mass of chlorine? Somebody in red. Yep, 35.45 AMUs, and just one. So we add them up. Oops. What you got? What you got? What you got? Somebody in something patterned. Oh. No, calculators.
I got it.
Okay. Let's
58.44.
58.44. What are your units? AMUs. So if these are AMUs, we're talking down at the level of individual atoms, right? Now let me ask you this question. The water example that's given in your notes, we're finding the molecular mass of water. Is this a molecular mass? I see several people no, yes, I don't want to commit. Okay, several of you are shaking your heads no. Mr. Cooper, why not?
Because sodium's on one side of your and chlorine's on the other.
Therefore, what does that mean, so?
If the ions transfer, or like one adding is one plus, or one plus and chlorine is one minus.
Everything you're saying is true, none of it answers the question.
There's no molecule.
There's no molecules! That's what he was trying to say.
That's what I was trying to say.
There are no molecules. Yes, everything you said was true. It just went all the way around the bush several times. There are no molecules of sodium chloride, so we can't call this a molecular mass. What we call it is a formula mass. Okay? So if we're doing a covalently bound compound, we can have a molecular mass. If we're doing an ionic compound, we call it a formula mass. You will screw up. It's fine. Okay, great, awesome. You throw down the gauntlet for yourself. You can call all of them formula masses, and nobody will yell at you. If you call an ionic compound a molecular mass, however, somebody will, pelt you with a chunk of sodium chloride or something. So,
Okay.
yeah.
I'm going to test that theory out.
Okay, in the depths of winter, you do that. So, this is the formula mass for sodium chloride. Let's practice one other formula mass. Let's practice a few of them. Okay, let's do... Ooh, I know. Let's do calcium carbonate. Give me the formula mass for calcium carbonate. Go. Okay. While you're all busily plugging away, let me pick on somebody. Somebody in Blue or black? Say somebody with jeans on.
Everybody.
Yeah, I know. I might have somebody who's not wearing jeans. Okay, somebody in blue or black. What's the mass of calcium? 40.02, is it? Oh, so rounded to 26.08. So we're rounding these to 2 decimal places. Okay, and we got carbon and we got oxygen, and there's only one of those. What's the mass of carbon? Somebody in red. 12.01. We have one of those. What's the mass of oxygen? Somebody who I haven't heard from yet today.
15.99.
16.0. And how many oxygens do we have?
3.
3. Okay. Hmm? That sounds about right.
Oh, not 109. I don't know why I said 1. 0.09.
Yeah. What are my units if this is a formula mass? AMUs. Okay. So somebody in the other class asked this question, and I thought it was a fantastic question, and it's one that no students ever asked me before. It was great. She said, but what is that? Is that for the whole thing? She had a really hard time expressing what she was asking, but so let's think through this. So calcium carbonate, we said it's in seashells, for instance. So if I took a bunch of seashells, I ground them up, I isolated just the calcium carbonate, and I had a pile of calcium carbonate. What I'm saying is I have a pile of calcium ions, and I'm going to simplify this for matters of, I'm going to do these as structural formulas, not Lewis dot diagrams. So I'm not putting in resonance, I'm not putting in the extra stuff. I'm saying I have a pile in which, for every 1 calcium ion, there is 1 carbonate ion. And when I'm talking about a formula mass, I'm saying that this little chunk right here, 1 calcium ion, 1 carbonate ion, has a mass of 100.09 AMUs. Does that make sense? Okay, good. Now, as you knew we would, let's make it slightly more interesting.
How do we make it less interesting?
No, we never make it less interesting. Okay, my old friend, oh yeah. Ammonium nitrates. So what's the first thing you got to do? Find all that stuff.
Stuff.
You could act happier about it.
Find all that stuff!
That was awesome. Completely insincere and fabulous.
Killed her play.
And that's on video.
I don't think you realized that.
I don't think he did. I think he had a moment where he forgot. Okay, what's the formula for ammonium nitrate? Who's got that part ready? NH what? NH4. And then what?
NO3.
NO3. Nitrate. Gotta be careful. Okay, so we've got 3 elements. An N, an H, and an O. What's the mass of nitrogen?
14.
Pardon?
14.00.
14.01. Check your rounding. And we have 2 nitrogens. Okay, hydrogen. 1.01. How many hydrogens do we have? 4. Oxygen. 16.00. And we've got how many? 3. Okay, add them up. Okay. Somebody I have not heard from today. Let's see, I'll go for anything in a bright color or a pattern. I have 2 with patterns, I know that, and I've got several more I think have bright colors. 80.06 AMUs. Okay. It wasn't that hard. You're just adding. The things to be careful about are making sure you get the right number of each element. Make sure you don't make a calculator error. Let's do one more, then we'll move on to our next topic. So, I know. Let's do magnesium bicarbonate. Magnesium bicarbonate. Oh boy. So, do our little tally here. We got Mg, we got H, we got C, we got O. I will now turn off the video.